Okay, so in this video, we're going to be looking at finding area or perimeter and circumference. The perimeter basically is, both of these objects are describing the total distance around an object. So if we're dealing with a polygon, then the perimeter is just adding up all of the sides. If there are relationships between the sides, like in a rectangle where two of the sides are guaranteed to be the same length, then there are some compact formulas that you can use, but basically the idea is add up the length of all of the sides and you get the perimeter. In the case of a circle, the exterior distance is called the circumference. And so there is a special formula for that because it doesn't have sides. So let's look at some sort of simple examples, and then we can go on and look at a more complex case. So in this example, we have a rectangle, and the properties of a rectangle dictate that opposite sides are going to be equal to each other. So in this case, even though two sides are labeled, this side is 7, and this side is 7, and this side is 5, and that side is 5. And so if we wanted to add them all up, then we would get the size of the rectangle. So 7 plus 7 plus 5 plus 5 is going to be equal to 14 plus 10, which is 24, which is the perimeter of the rectangle. And for this other object, again, if they leave off sides, it's not because they have no length or they're unknown. It's because they're using the fact that the opposite side, the side in a similar position, is going to have the same length as the one that's been labeled. So in this case, this side is indicated to be the same as this side, and this side should be assumed to be the size of this one, and this side are also equal to each other. So again, we can add up the sides that we have, and then also the assumptions that we are making about the other sides because of the symmetry of the shape. And if we add these up, we get 20, which is the perimeter of the irregular hexagon. And so other objects would be done the same way. So if we had values for A, B, and C in our triangle, then we would add those up and we would get the perimeter of our triangle. In the case of our circle, if we specify a size of the radius, then we would plug that in for the radius here and we would get a value. So for instance, if the radius is 3, then the circumference would be 2 pi times 3, or 6 pi. Now, when we get to more complex shapes, we can also find the sizes of those perimeters. We would need some information about the object, but then we could go ahead and use other shapes that we know the perimeter or circumference of in this case to get that information. So this shape is being indicated that we have some sort of a rectangle and it's capped with a half circle. So in that case, what we would do, let's label some of our sides. So let's say I know that this side is 6 units long and this side is 10 units long. Now, what I know from that, and I don't need to know any other information, but what I know from that is that, again, this bottom rectangle, this side over here will also be 10. And this is the entire diameter of this half circle up here. So the radius is going to be 3. So if I put that perimeter together, the bottom 3 sides are going to be 10 plus 10 plus 6. And then the top half of this half circle is going to be 1/2 the circumference of 2 pi times the radius. But again, this is the diameter, so the radius is half of that, so times 3. And so what I'm going to end up with is 26 plus, the 2's are going to cancel, 3 pi. Now, this is a weird number, and unless you're provided a value for pi or you're told to round or estimate, it's a good idea just to leave it as it is as an exact answer. Sometimes students will get into trouble because they don't use the value of pi that is provided, or they don't use an accurate enough one. Some problems will tell you use 3.14, then use that. If they don't specify, you should use ones in your calculator that have many, many, many digits in it, rather than 3.14, and get a more accurate value if you do need to convert this to a decimal.